All right, we are looking at target 1.6. Our mastery learning objective is I can use proportional parts within triangles to solve for the missing pieces of a triangle. Okay? So we're going to start with a whole bunch of, what's the word I'm looking for? Vocabulary to see what like a dilation is, right? That's not our mastery learning objective. I just read it, and that's not at all what we're doing. That's what we did the other day. That was 1.5. So our mastery learning objective is I can dilate a figure, actually. Let me do that. Okay, so we're looking at these dilations. So a dilation itself is sorry, this all got messed up. Changing the size of a figure while keeping the shape the same. And so we call this a similarity transformation. If you remember last year, you learned about some other transformations, like transposing, which moves the shape, rotating rotates the shape, right? Or reflecting. Similarity why do I keep writing F's as P's? Transformation. And reflecting, right? Those were all congruency transformations. This figure didn't change shape or size. Where dilation is just a similarity transformation. It changes size but not shape. Okay? So when you have a dilation, the figures are similar because all those angles are still the same. The sides stay proportional. All those things. Okay? Our center of dilation is the point which the figure is dilated from. And then we have our scale factor. And we looked at scale factor before. Remember, it's that proportion. I cannot spell today for the life of me. Okay? And remember, it's K equals, and it's the new over old. Can't do anything today. So if we look here, right, these were dilated around this point in the center. And our scale factor could be like the length of JK over the length of AB. Again, because this is our new image and this was our old image. So be careful about that. All right, so then when we have that scale factor, we have two things. We have an enlargement. An enlargement, the figure gets bigger. And if it's an enlargement, then K is greater than 1. And then we have a reduction, and a reduction is the figure gets smaller. And K is less than 1. so let's look at some examples. Determine whether the dilation from A to B is an enlargement or a reduction. Then find the scale factor. Okay? So I'm starting, right, from A. I should have used blue there. Keep with our colors that are on here. From A to B. So B is our new, and A is our old. So here, if I'm trying to find our scale factor, is new over old. And I want to use the lengths of the sides. And here, right, our new, again, is this B. I want to use a straight side. Here's a straight side. And it looks to be 1, 2, 3, right? I'm counting this as a half and that as a half. That's easy enough. And A is 1, 2, 3, 4, 5, 6. Right? So then K just equals 1/2. Okay, so it's kind of like how we set up those proportions at the beginning of the unit, right? We found like the scale factor between the sides and make sure all 3 sides had the same scale factor, all those kind of things, okay? But now we know going from A to B, K is less than 1, and so this is a reduction. Also easy enough to look at the picture and go, hey look, yeah, it's getting smaller. Okay. Alright, looking at our next one, again, K equals new over old. And then I'm going to choose a side on my new first, and new is that B figure. I'll choose this one, 1, 2, 3, 4. And then this side, which is 3. Again, straight sides. Don't do any of these like diagonal sides because it's harder to tell the length of those. Just straight up and down or straight across. So 4/3, and that doesn't reduce. So K is 4/3. Well, 4/3 is larger than 1, so that's an enlargement. The biggest mistake I get on this is something like this. It'll be like 4/3, and so people are like, oh, it's a fraction. It's less than 1. Just because it's a fraction doesn't mean it's less than 1. So be careful with that. If it's a fraction, you have to look at the number on top. 4 is bigger than this 3, right? Therefore, 4/3 is bigger than 1. Okay, if the number on top is bigger than the number on bottom, then that is larger than 1. So be careful with those fractions. All right, go ahead and turn to the next page. Now we're actually going to draw some dilations. Right? Graph the quadrilateral J prime is what how that little tick mark is pronounced. J prime, K prime, L prime after a dilation with a scale factor of 2. And centered at 0, 0. And so here's my center. So how we do on these, when they're centered at 0, 0, they're much easier, but we look how far away it is from that point, and then we multiply those by the scale factor. So for example, I'll start with J is over 2 up 4. So I like to put right 2 and up 4 from the center. Okay. And then we're going to multiply that by 2. So then J prime is over, right, 2 times 2 is 4, over 4, 4 times 2 is 8, up 8. Okay. So I'm going to start at my center, I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. There's my J prime, okay? Again, at 0, 0, it's easier because this is the point. The point is 2, 4, and the point is 4, 8. But kind of learn this process for these ones because when it's not centered at 0, 0, it gets a little trickier, okay? So now point K is here. It's 1 right, 1 up. So right, 1, up, 1. And then our scale factor is 2. So that will give us our new K prime. That is 1 times 2 is 2. So I'm going to go right 2. 1 times 2 is 2. So I'm going to go up 2. The direction will never change. Okay, so I'm going to go right 2, up 2. That's going to be the new K prime. And then we have L is right 4. And then nothing, right? Doesn't move up or down. Still want to multiply that by our scale factor. And we get our new point of L prime, which is right 8. And then 2 times 0, or 0 times 2 is still nothing. Okay? So now this point is going to go 1, 2, 3, 4, 5, 6, 7, 8. And that's L prime. Don't forget at the end to connect your dots. We're dilating the whole figure, not just the points, so we want those lines in there at the end. And this isn't a quadrilateral, it's a triangle. Oops. J prime, K prime, L prime is our new shape there. All right, let's look at our next example. Graph triangle KLP. With vertices at K, -4, -6, L, 0, 4, and P, 4, -6. So let's start by doing that. K is going to be at -4, -6, so K is going to be down here. L is going to be at 0, 4, which is up here. And P is going to be at 4, 6, -6. So there's P. So here's our lovely triangle. So again, we're just graphing those. And now we want to transform KLP by a scale factor of 1/2. And then graph, but I didn't give you a center, so let me do that. Centered at, let's do 6, 4. That's a fun one. Okay, so our centering point is going to be 6, 4. Okay, when your center is not 0, 0, okay? Again, we're going from this point and we're seeing how far things away are. Okay, so for K, right, K is at 4, -4, -6, so I'm not looking at the point. Right? If I go here, I have to go 10 left and then 10 down. Right? So I'm going left 10 and down 10. Then I'm going to multiply that by 1/2. So for my new K, we're going to go left 5 and down 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4. There's my new K prime. Okay. Same thing with L. My L is just 6 left and then it doesn't go anything else, right? It doesn't have to go up or down, times 1/2. So that gives me an L prime of, well, I'm going to go left 3 and then still 0, right? So if you ever have a 0, it just stays that way. So starting here, I'm going to go 1, 2, 3. There's my L prime. And then P is our last one. If I look here, it's over 1, 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's left 2, down 10. So our new P prime is going to be left 1, down 5. Starting here, I'm going to go left 1, and then 1, 2, 3, 4, 5. And there is our lovely new shape. And if you look at these, they do look similar. This triangle does seem to be about half the size of that one. Okay, so we're cutting in half how far from the center we are. Like in our other example, we were doubling how far from that center we are. Okay. I'm not going to worry about this last problem. You can pretty much just cross it out. So that is it, and I'll see you guys tomorrow.